Okay, so today I'm going to show you how to recreate the very familiar tortoise and hare problem, where the hare races the tortoise and the hare goes faster, but because he thinks he's so great, he takes a nap and then ends up losing. So I'm just going to give you some information about the problem very fast. I'm going to put it here and we'll delete it later. The hare travels at 800 centimeters per minute, and the tortoise travels at 200 centimeters per minute, and then the hare runs for 5 minutes and takes a 20-minute nap. Now this is just on the side, we're going to get rid of this later. So, the first thing we want to do is we want to graph, in respect to time, the tortoise, its function. So that's just a linear equation that's just going to be 200x, where 200 is 200 centimeters per 1 minute. So in x, we're going to be in minutes. Now as soon as I put that in, you see I almost have a vertical line. So we're going to change our window here. We're going to go, so you go into graphics. You can do that by hitting edit or just right clicking. And I'm going to want my x-min, I'm going to do like -10. I always give myself a little buffer. And my max-min, let's do, I don't know, we'll do 100 for now. Maybe we'll change it later. And my y-min, I'm going to put -10. And my y-max, let's do, well, we know in 1 minute the hare is going to go 800. So let's do 3000, just to see where that puts us. It still looks like it might be a little off. Let's go ahead and increase this up to 5000. We'll do 6000 just to be safe. So there we go. Looks a little better. We'll zoom out a little bit. So this is this function, but you can see it's down here. I don't want any of this, so I'm going to show you how to revise this function. In the input bar, if you type in the word function, it'll give you a couple options: list of numbers, a function, an x value, and an n value, an expression, parameters, start value, end value, etc. We don't want that. We just want the second one. So if you go ahead and hit enter, what's our function? Well, it's 200x. The start value is going to be 0. We'll make the end value just some large number. We'll do 100. Why not? Hit enter. So now we're actually going to go ahead and delete this guy. Just click on it and hit backspace. So now you can see if I actually zoom out, this function should end, yeah, right there. But that's okay because we're concerned about what happens near here. So one piece of information I forgot to tell you was the race is 5,000 centimeters. Okay. So in order to get to 5,000 centimeters, zoom in so we can see 5,000. It's going to be right here. So it looks like the tortoise gets there about 25 minutes or so. Well, I don't know yet. So that's okay. So now we're going to put in the hare's function. Now the hare function is a little more complicated. So we're going to type in function. Now our function is going to be a piecewise function, right? Because he runs 800 centimeters per minute, then takes a 20-minute nap, and then runs again. So the way you do this is you're actually going to use an if-then statement. If you're familiar with coding, it's conditional. So this is also how you put in a piecewise. So it's if, capital I, F, and then 2 parentheses. So this is where our statement's going to be held. Now, we're going to use if x is between 0 and 5. So if x is less than or equal to 5 and greater than or equal to 0, then you put a comma, that's your then statement. You're going to have the function 800x. Okay? Then you put in a comma because you're ending it. Or if that was it, you hit enter. But I'm going to add some more statements. So now if you're between 5 and took a 20-minute nap, so 25, then your new function is going to be 5 times 800 is 4,000. So we're just going to create that line of 4,000, and we'll see that in a second. We're going to do one more. Now we're just going to say if x is greater than or equal to, I should do it this way, 25 is less than or equal to x. Then we get the function again, 800x. But this isn't right because we're not starting at the origin. So we have to do a shift of how much? I think it's minus 25 and then plus 400. And I think that's right. We'll check it out. We'll go from 0 to 1,000 again, or 100. Ooh, see, I was a little bit off with my function here. See how it drops it way down here? It looks like this last one, should be plus 4,000. There we go. Now my piecewise connects. We can see that right here. My piecewise actually connects. So again, to go over what that long equation was, double click here. I'm going to zoom in. All these buttons. There we go. So if, and remember to do this, it looks like this on the computer. If x is between 0 and 5, then you get the function 800x. If x is between 5 and 25, you get the function just 4,000 because he hasn't moved any distance. And then if x is greater than 25, you get this function right here. So 800 times x minus 25 plus 4,000. Now it's plus 4,000 because it has a y-intercept of 4,000, but I shifted it 25 units to the right. There are obviously other ways to rewrite this. This is just how I thought to write it. So now that we have that, sorry. There we go. So now that we have that, we can look at some more things. So I still don't like this window. It's still kind of hard to see. So I'm actually going to change my window one more time. I really only need x to go from, we'll say -10 to, it looks like maybe 40. We don't need it very large. And it kind of widens everything for us. Makes it a little nicer to see. My x values are okay. My y values are, we'll take that down to 7,000. Okay, so that makes it look a little nicer. We can still move it around. We can still zoom out if we want. So now what you're going to do is we're going to plot some points. But to do that, we want to have a slider, because what I want to have eventually is them move on their own. So I put a slider right here. Call it A, call it whatever you'd like. I'm going to call it T for time. And I'm going to set the interval from 0 to, let's say we go to, I don't know, we'll go to 100. Always change it. And I'm going to do increments of 1 because I don't want them to take that long. Actually, it looks like we really only need to go to about 35. So that's what we're going to fix that now. We double click that, and we're going to go to 35. Because 100 is just going to be way too large. So now, we're going to put our points in. So you put a parentheses, your x value is t, and your y value is going to be f of t. And you hit enter. So that generates this point right here. If you move t, you can see it move along that piecewise function like so. Then we're going to do one more point. We're going to have our same input, t, but this time our output is going to be g of t to represent the tortoises. So now you've got 2 points that move along at the same rate of time. So to make these points a little more visual, I'm going to click on A, click on this little graphics triangle. I'm going to make the hair, we'll make it, doesn't really matter, I'll make it red. I'm also going to make it larger, a little easier to see. I'm also going to put my values on it. You don't need to have that, but I'm going to. I'm also going to rename it. So to do that, you right click on the point and hit rename, and you are the hare. So we'll call you Hare. Do the same thing for the tortoise. I'm going to make the tortoise, make it pink, and we'll make it larger, a little easier to see. And we're going to rename it Tortoise. Hit OK. Now you've got your tortoise right here. Oh, I need to put the value on it. Again, you don't have to do that. So now as t moves, you can see, maybe I do want them to count by decimals, because it looks like they move a little bit way too fast. So I'm actually going to go into this one more time, and I'm going to increment this by 0.1. So now if I right click this bar and hit animation, you can really see them move. So remember our whole goal. We want to know who wins. Well, we're only going 5,000 centimeters, so I'm going to type in the line y equals 5,000. And then to make it a little more realistic, I'm going to make it look like a finish line. And go right here, I have to click on the line, and we'll make it one of these brackets, and we'll make the finish line, black's fine, but we're going to make it a little thicker so it's easier to see. And there's our finish line. So now we can ask, okay, where do we intersect, and those kind of things. We can move T. Okay, who's going to win? Oh, it looks like it's going to get close, but we do see the tortoise crosses that black finish line before. But then you can lead into questions of when do they intersect and things of that nature. And I'm going to change this value. Instead of being 25, I'm just going to call it B. Hit OK. Oh, I'll create a slider for B. Sorry, we don't need this one. So it kind of messed things up because our slider's not where it needs to be. This needs to be at 0. This needs to be at 25. So now if you move B, you can see it move like this. But that really messes things up, because when B is 0, this y-intercept is 4,000. What we're going to do here is we're actually going to change our piecewise function a little bit. So this is okay how it is, except here I want this value to just go to B, and I want this one to be B. So watch what happens here. I'll explain why I did that in a second. See how it moves like this? So all I have to do now is change my y-intercept. Well, I know it should be about there. So to do that, I just gotta make that 4,000 again. And obviously B can only start at 5, and then it's good after that. So the last thing we have to do is change our slider to start at 5. Remember, it doesn't start napping until 5 minutes. So now you've got this piecewise function that moves. So now you can talk about, okay, look, about right here is where he could have napped and tied. Anywhere over here, he would have won for sure. And that's how you make the tortoise and hare problem.